Hi friends, in this video we are going to discuss about the series and parallel connection of the capacitor. Okay, so why we are going for the series and parallel connection of capacitors means, so whenever we are going to analyze the electrical circuits or networks, so without knowing the series and parallel combination of resistances, capacitances and inductances, so it is not possible to get the solutions. So for that, in the last video I explained about the concept of series and parallel combination of resistances and how to find the equivalent resistance when resistances are connected in series and when resistances are connected in parallel. So I already explained in the last video, and in this video I am going to explain about the series and parallel connection of capacitors. Okay, so I already told you in the last video how to identify the series connection and how to identify the parallel connection. Okay, so without knowing the identification of series and parallel connection exactly or perfectly, then it is not possible to get the exact equivalent values. Okay, so for that, first we need to identify whether the capacitances are connected in series or in parallel. So first we need to identify, then after that we need to calculate the value of total equivalent values. Okay, so here our topic is series. So series and parallel connection of capacitors. So series and parallel connection of capacitors. Okay, now see, we already know that the symbol of capacitors, yes or no? So the symbol of capacitor is exactly like this. Okay, so for example, this is the C1, capacitor C1, and for example what I'm doing, I'm considering another capacitance like this. For example, this is the C2 capacitor. Okay, now this is the C1 capacitor and this one is the C2 capacitor, for example. Now when these two capacitors are connected in series, then we need to find the equivalent capacitance. Then how to proceed to find the value of equivalent capacitance when capacitors are connected in series? Okay, so just to observe the thing, the most important thing when we are going to comparing the resistances and the inductances, this is completely opposite to the calculation of equivalent resistance and calculation of equivalent inductance. Okay, so we know that when two resistances are connected in series, for example R1 and R2 both are connected in series, to get the value of total resistance when these two are connected in series, we can directly add R1 plus R2. Okay, for example the value of R1 is 1 ohm, value of R2 is 1 ohm, then we can directly say that, so 1 plus 1, that is the value of resultant resistance, that is 2 ohms. But in case of capacitors, when two capacitors are connected in series, this connection, to get the value of capacitance from this connection, this is exactly equal to the parallel combination of resistances. Okay, for example, see, this is C1 and this one is C2. If suppose both are connected in series like this, okay, both are connected in series like this. For example, I am considering this is the terminal A and terminal B. Okay, now the question is to get the total capacitance of this series connection of C1 and C2. Okay, so just now I told you how we are following in case of the resistance concept. If two resistances are connected in parallel, then whatever the procedure we are following to get the total resistance, so that procedure we need to follow in case of capacitance if capacitance are connected in series. Okay, that is, so here when two resistances are connected in parallel like this, okay, when two resistances are connected in parallel like this, so to get the value of total resistance, what we are doing, so we need to take the reciprocal of the total resistance, that is, so 1 by RT is equal to 1 by R1 plus 1 by R2. So after simplifying, you will get the value of RT is equal to R1 into R2 divided by R1 plus R2. Okay, so this is the value of total resistance if two resistances are connected in parallel. Okay, so this is the procedure we need to follow to get the value of total resistance. So when two resistances are connected in parallel, we are proceeding this procedure. Yes or no? We are proceeding with the procedure of this, and same procedure we need to follow in case of capacitance. That's why I'm telling you, when two capacitors are connected in series, we need to follow this procedure. Okay, we need to follow this procedure. If two capacitors are connected in parallel, then we need to follow with this procedure. Okay, that's why I'm telling you the procedure of resistances and inductances is same, but the procedure of capacitance is completely opposite to the procedure followed by the resistances and inductances. Okay, now see here, for example, the value of C1, for example, the value of C1 is 2 farads, and the value of C2 is, for example, 5 farads. Now to get the value of this series combination of capacitances, always we need to go for the 1 by Ct, that is 1 by total capacitance is equal to 1 by C1 plus 1 by C2. So from this you will get what? 1 by C total is equal to 1 divided by 2 farads plus 1 divided by 5 farads. It means what? So 1 by C total is equal to, so 2 into 5, this is the denominator value by taking LCM, and this one is a 5 plus 2. So here 1 by Ct is equal to 2 plus 5 divided by 2 into 5. So by getting the value of total resistance, you can directly say that 2 into 5 divided by 2 plus 5, that is equal to 5 into 2 means 10 divided by 7. So this is the value of total capacitance when both the capacitors are connected in parallel. Okay, now see the procedure. When we are going to talking about the series connection of capacitances, we are following this procedure which is equal to the parallel combination of resistances. Okay, so this is the procedure we need to follow when two capacitors are connected in parallel. Okay, now coming to the parallel combination of capacitances. Okay, now see the parallel connection of capacitances. Parallel connection of capacitances. For example, we have two capacitors. For example, two capacitors are connected in parallel. For example, this is C1 and this one is the C2. For example, now this is terminal A and this is the terminal B. Okay, so this is the C1 and C2. For example, the value of C1 is, for example, 2 farads. And the value of C2 is, for example, 10 farads. Okay, now the question is get the total capacitance from this connection. Okay, so get the Ct is equal to how much? So just now I told you the procedure we are following in case of capacitances. If two capacitors are connected in series, we need to follow the procedure which is equal to the procedure followed in case of the parallel combination of resistances. And here, if two capacitances are connected in parallel, then we need to proceed the procedure which is followed in the series combination of the resistances. Okay, so what is the series combination of resistances? So we already discussed just now. Okay, so for example, this is R1 and this is R2. So here these two are connected in series. Now get the value of this total resistance. If these two are connected in series, how we are following? Directly we are adding R1 R2. Okay, to get the value of RT. Now same procedure we need to follow here when capacitors are connected in parallel. Okay, now here from this, so total capacitance is equal to, directly we can add these two capacitances. Okay, so one total capacitance Ct is equal to 2 farad plus 10 farad, that is equal to, total is equal to 12 farads. Okay, so like this we need to follow whenever we are going to solve the problems in networks or circuits. So when two capacitors are connected in parallel, we need to follow this procedure, and when two capacitors are connected in series, we need to follow this procedure. Okay, so this is a procedure we need to follow whenever we are going to solve the problems based on the series and parallel connection of capacitances. Okay, so thank you so much for watching.